Good day, sir. I am Francis Amil Culiano from BSE 2C. I am your student in Circuito. Today, I am going to share with you what I have learned during in our discussion in Circuito. And now I will discuss to you about impedance. What is impedance? Before we ask that question, let's talk about resistance. What is resistor do on a circuit? A resistor opposes the flow of the electrical current. Here a symbol of resistor. The unit of resistance is ohms. Whenever you increase the resistance of a circuit, the current flown in that circuit decreases. The resistance will increase, then the current will decrease. And so resistance provides opposition to the flow of DC current or direct current, and can also oppose the flow AC current as well. And now, let's talk about impedance. Let's see what is the difference between resistance and impedance. And now, impedance is very similar to resistance. Impedance is represented by letter Z. Like resistance, the unit is ohms. But impedance represents of opposition to the flow of electrical current in AC circuits as opposed to DC circuits. Now, the elements that impedance of AC currents that include the resistor, the inductor, then the capacitor. The formula for impedance is Z square root the resistance squared plus inductive reactance minus capacitive reactance squared. This the squared difference of inductive reactance and capacitive reactance. Let's talk about the formula of inductive reactance. Inductive reactance 2 pi times frequency times inductance. Then the capacitive reactance 2 pi frequency, then the capacitor. Then we know that the formula of the inductive reactance and the capacitive, and the formula of impedance is this. Let's go to example. Okay, we have the AC signal power source. It's connected to resistor, the capacitor, then the inductor. Then the resistor is 100 ohms. Then the inductor or the capacitor is 20 microfarads. Then the inductor is 200 millihenries. Then the voltage is 120 voltage. Then the frequency is 60 Hertz. Okay. First, we will solve the capacitive reactance. Capacitive reactance, copy the formula. This 1, 2 pi frequency, then the 1, 2 pi frequency times the capacitor. Okay. 1, copy the 2 pi, then the frequency is 60. Then the capacitor is 20 microfarads. This 10 raised to 6. Then the result of the capacitive reactance is 132.6 ohms. Next, we will solve the inductive reactance. 2 pi frequency times inductor. Okay, 2 pi, then the frequency is 60. Then the inductor 200 times millihenries is to 3. Then the result is 75.4 ohms. Okay, we have the capacitive reactance and then the inductive reactance. Let's go to, we will solve the impedance. The formula of impedance is impedance square root r squared plus inductive reactance minus capacitive reactance squared. Okay, impedance, the resistor is 100 squared plus the inductive reactance, this 75.4 minus the capacitive reactance, the 132.6 ohms. Then don't forget the squared. Then compute the result of impedance is 115.2 ohms. That is the impedance of the current. Next, we will solve the current flow. Okay, the formula of current is I voltage over the impedance or the resistance. The voltage is 120, then over the impedance 115.2. Then the result is 1.04 ampere. That is the current flowing. We have the current 1.4 amps. And now let's compute the frequency. The formula of frequency is 1, 2 pi square root the inductive or the inductor and the capacitor, square root of the inductor capacitor, 1, 2 pi, then the inductor The inductor is 20. The inductor is 200. The inductor is 200 millihenries. Then I convert the millihenries to henries. 0.2 times the capacitor, the 20 microfarads, times 20, then times the microfarads. Then the result is 79.6 hertz. Now, that's all. We solved the impedance, the current flowing, then the frequency. That's all. Thank you.